I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem related to power series from the section complex analysis that appeared in the CSIR National Eligibility Test held on December 15, 2019. And this question is from part C, which is a multiple select question. There can be more than one answer, and this question carries 4.75 marks. The question ID is 187-980-1820. This question is suitable for all these examinations. Right. The given question is, consider the power series f of z is equal to sigma n is equal to 0 to infinity minus 1 to the power of n into z to the power of 2n plus 1 by 2n factorial. Which of the following are true? We are given four options. Option 1, radius of convergence of f of z is infinite. Option 2, the set consisting of f of x where x belongs to R is bounded. Option 3, the set consisting of f of x where minus 1 less than x less than 1 is bounded. Option 4, f of z has infinitely many zeros. Right. We now discuss the solution of the problem in detail. We have f of z, which is the power series sigma n is equal to 0 to infinity minus 1 to the power of n into z to the power of 2n plus 1 by 2n factorial. You take a z common, z outside the sigma, then z into sigma n is equal to 0 to infinity minus 1 to the power of n z to the power of 2n by 2n factorial. So this series under the sigma is the famous cos z expansion. So this is z into cos z. It is an entire function. Why it is an entire function? Because z is an entire function, cos z is an entire function, their product is also an entire function. Agreed. So it is very well known, if it is an entire function and this will not have any type of singularities. There are no singularities at all in the whole of the complex plane. So we discuss now the option 1, radius of convergence of f of z is infinite. Now, there are many ways of computing the radius of convergence, but I prefer this one. Capital R is the radius of convergence of the given series about z naught is equal to 0, about the origin. And it is given as, it is the distance between the z naught is equal to 0 and the nearest singularity of this series. There are no singularities for f of z at all. So therefore R is equal to infinity because z cos z has no singularities as it is an entire function. So R is equal to infinity. So the radius of convergence of f of z is infinite. Thus option 1 is true. We move on to option 4. It says f of z has infinitely many zeros. Is it so? Yes. Yes. It has infinitely many zeros. How? Now, clearly f of z is equal to z cos z is equal to 0. When z cos z is 0 means z is equal to 0. Or cos z is equal to 0. Cos z is 0 when z is equal to 2n plus 1 pi by 2 n belongs to the set of integers. How many? Infinitely many. So, thus f of z has infinitely many zeros. Thus, option 4 is also true. Move to the next slide. So, option 2, the set consisting of f of x, x belongs to R is bounded. And option 3, the set consisting of f of x where -1 less than x less than 1 is bounded. Now, we have the set of all f of x, x belongs to R is equal to the set of all x cos x, x belongs to R. Now, is it bounded? That is the question. Now, for the sequence xn is equal to 2n pi, n belongs to n. F of xn, their values, is 2n pi cos 2n pi, and cos 2n pi is 1 for all n belongs to z, n belongs to n, even, is okay, and that is 2n pi, which tends to infinity as n tends to infinity. As n tends to infinity. That means this function, this set f of x, x belongs to R, is an unbounded set. Thus, this set is not bounded. Therefore, option 2 is not true. Agreed. Go to option 3. But now, mod of fx is modulus of cos x less than or equal to mod x. Cos x is bounded. Mod cos x is less than or equal to 1. So, mod x less than 1 and mod x. So, mod of x cos x is less than or equal to mod x, correct? But -1 less than x less than 1 means mod x less than 1. So, now this mod x is less than 1 when mod x less than 1. So, that means it is bounded. It is bounded. Thus, the set is bounded. So, therefore, option 3 is true. And how many options are true? Options 1, 2, 1, 4 and 3. Option 2 is not true. So, thus, the answer to this question is options 1, 3 and 4. And 4. Option 2 is not true. That is the detailed discussion of the solution of this problem. And this question, a very simple and straightforward question. I am sure that you like this problem, and this also suggests that the radius of convergence, what are the different formulae for the radius of convergence, you gather that information and do some problems thereon, and prepare a good notes that will help you. I am sure that you have understood the solution of this problem. Thank you for watching the video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We hope to meet you once again in another episode of learning. Keep learning. I wish you all the best. Thank you.